Hello guys, welcome once more to another video in our YouTube channel. So in today's video we are going to be looking at the equation which reads, what is the minimum value of the function 33 divided by the absolute value of f of x minus 6 then minus 12, where f of x is 3 sine of negative x plus 4 cos x. So this particular question was sent to me by a student, and then I tried to get the proposals from other teachers and also students as well to see how they understood this question, because there was a very important step in the solution where once you fail that step you're going to get the wrong answer, and unfortunately the wrong answer is still going to be among the options. So that's why I decided to do the video. Alright, so without wasting much of your time, let's get started. Okay, so the first thing I would like us to identify is that the function 3 sine negative x is an odd function. Sorry, the function sine x is an odd function. So sine of negative x will be written as negative sine x. So doing that, we convert our f of x to resemble this, that is f of x equal to negative 3 sine x plus 4 cos x. Now if we rewrite it, we are going to get 4 cos x minus 3 sine x. Now these are the steps you have to follow in order to successfully solve this equation. The first thing is that we have to make sure we write f of x in the form r sine x plus alpha, where r is positive and alpha is an acute angle, or you write it in the form r cos x plus alpha. Okay, so me, I choose sine x, you can choose cos x. We are still going to get same results at the end of the day when we find the minimum value. Alright, but by the expansion rule of sine x plus alpha, if we expand, we are going to get r sine x cos alpha plus r cos x sine alpha. If we compare the coefficients of cos alpha and sine alpha with that in this expansion, we are going to see that the coefficient of cos x here is 4, but in our expansion the coefficient of cos x is r sine alpha. Now in our expansion the coefficient of sine x is r cos alpha, but here it is negative 3. So we can equate those corresponding entries and we get two equations, and we have to solve for the two unknowns. So the first equation will be r cos alpha to be the coefficient of sine x and r sine alpha to be the coefficient of cos x. Now if we square both equations and add them together, this is what we are going to get. We are going to get that r cos alpha all squared plus r sine alpha all squared to be equal to negative 3 all squared plus 4 squared, which gives us 9 plus 16, that is 25. Now we can factorize r squared from the two terms, and then we have r squared into cos squared alpha plus sine squared alpha equal to 25. But we know that for all angles alpha, cos squared alpha plus sine squared alpha is 1. That is a basic trigonometric identity. So it therefore means that our r squared is going to give us 25, and since r is positive, r normally will give us plus or minus 5, but since r is positive, then we say r is equal to 5. From there, we don't actually need to find alpha, okay, in order to solve this question. So I'm not going to find alpha, though you could replace your r with 5 here and then you make cos alpha the subject of the formula, then you can get alpha. Okay, it all depends on you. But anyways, I'm just going to allow alpha as alpha. So my f of x becomes 5 sine x plus alpha because my r has given me 5. So I have successfully completed the first set, that's the first process. Now after getting our f of x in the form r sine x plus alpha, what then do we do? We start by bounding the function. So we know that for all values of alpha and for all values of x in the set of real numbers, sine of x plus alpha is always between -1 and 1. That is, x plus alpha is an angle, and the sine of any angle will always lie between -1 and 1. So that is how we begin building our proof. Now we come back to the function we want to find its minimum value, and we study the function carefully. Whenever you have a function that is rational, you begin with the denominator. And if you look at this denominator, there's an absolute value there. So I'm going to begin with what I know, which is the f of x. Okay, so since I've written f of x in the form 5 sine x plus alpha, then I know that sine x plus alpha lies between -1 and 1. For me to get f of x, I need to multiply the all through by 5, so that I'm going to get at the center f of x, and then I start subtracting 6. I take the absolute value, I subtract 12, I take the reciprocal, then I multiply all through by 33. All right, so let's multiply all through by 5. We know 5 is positive, so the inequality signs remain unchanged. So -1 times 5 gives us -5. Sine x plus alpha times 5 gives us 5 sine x plus alpha, and 1 times 5 gives us 5. Now we are going to replace the middle term with f of x, because we have written f of x in the form f of x is equivalent to 5 sine x plus alpha. Alright, so if we come now to our denominator, we are done with f of x, but now we need f of x minus 6, so we have to subtract 6 all through. So -5 minus 6 is -11, and at the center, that's the middle term, we have f of x minus 6, and then here we have 5 minus 6, which is -1. Now the misconception begins from here, alright, and I'm going to explain detailedly, because some people told me that, alright, when you arrive in this case and you want to take the absolute value, you're just going to make the lower part to be 0 and the upper part to be the biggest one, which is 11, which is not actually the right methodology. So I'm going to explain detailedly what you're supposed to do here. In which cases are you supposed to take the 0, because there are cases where you have to take 0, but in this case, once you do that, you get a wrong response, and like I said, that wrong response is going to be in the options. I think when you do that, you're going to get B as your answer, which is incorrect. All right, so let us see the right methodology to use to solve this when you arrive in cases like this. So we are going to study the absolute value function specifically, and you're going to know its properties. So let's try to plot the graph of the absolute value of x. The absolute value of x is my function here, but we need to know that the absolute value of x is equal to -x once x is negative and +x once x is positive. Don't be thinking that the absolute value of x can be a negative value, because we know that no matter the value of x, the absolute value will always give us something positive. But now from its definition, you might see a negative x here, and you have a feeling that why is it that the absolute value can be negative? But it is not so. Don't forget that the absolute value of x is -x, provided x is negative. So if this x is negative, once you multiply it with this negative sign, it becomes back positive. And the absolute value of x is +x once x is positive. So you see, in either case, it is always positive. So let's draw the graph. So we have our xy plane, vertical for y, horizontal for x. They intersect at 0. Now let us first of all plot the line y equal to x. So it is just a line that passes through the origin, and it has this orientation because the gradient is 1. Now what about the line y equal to -x? It's just kind of like this. All right, you have a line that also passes through the origin, but since its gradient is negative, it is perpendicular to this other line, because the product of their gradients are both -1. The product of their gradient gives us -1, and both of them passes through the origin. So we have y equal to -x in blue and y equal to x in red. All right, now how then do we plot the absolute value? We now come and then we try to cancel off some portions of the graph. Remember that this red line is the function x, okay, but now for the absolute value, we need to take x provided it is in a positive region. So it means that I'm going to wipe the part below the x-axis. That's where x is negative, sorry. Okay, so you see, I'm just going to take this red portion in this positive x region. Now for the other part, which is -x, remember that we are dealing with it when x is negative. It means you are going to wipe this portion where x was positive, and we take only the portion where x is negative. So that is the absolute value function. Some properties, it is continuous at 0, but it is not differentiable at 0, in a case where you see that in an MCQ. All right, so let us try to analyze this graph. Now I wrote down some things, and I don't know if it's going to help, but I think it's going to help. Now you see that this graph actually has two portions. We have a portion when x is positive, and we have a portion when x is negative, and those two portions have different sense of direction and different orientations. Now when x is positive, okay, now after I took a case where you have your x being between two numbers a and b, therefore the absolute value of x will still lie between a and b, provided that a and b are both positive and b is greater than a. Because you see that in a portion when x is positive, the graph is increasing. You see it begins from 0. As x is increasing to the right, the graph is also increasing. So it therefore means that once x is positive, the absolute value function is increasing in that interval. And by the definition of an increasing function, if let's just say x lies between a and b, then I want to compute the absolute value of x all through. That's the function I'm bringing into play. Then the bounds are going to remain the same because the function is increasing in that interval. Okay, now what about if x now is in a negative interval, meaning that if x still lies between a and b, but this time around our a and b are both negative, and then b is greater than a or a is less than b. You now see that we are involved with this blue portion of the graph. Now you see that in this blue portion of the graph, once x is going towards the right, meaning increasing, the graph is rather decreasing. If x is going towards the left, meaning x is decreasing, the graph is instead increasing. So you see that the graph of negative x is a decreasing graph, okay, because you see that as x is going towards the right, meaning when you're moving from -3 to -2 to -1 to 0, the graph is rather decreasing, as you can see the orientation. Okay, and when the graph is decreasing and you want to take the absolute value, in fact, if you have x being between two negative values, in fact, if you have x, okay, being between two values and the function is decreasing in that interval, once you want to compose, like you want to take f of that value of x, where f is your decreasing graph, you're going to switch your bounds. This is what I'm saying. Our x here is between a and b, and then a and b are negative, and then b is greater than a. We have seen that if you want to take the function absolute value of x, it's not going to be like the first case, because in the first case your function was increasing in that interval because the interval was positive. But in the second case, the function is decreasing in that interval since the interval is negative, and we have seen it clearly from the graph. And since the function is decreasing in that interval, when we are introducing the function the absolute value, we are going to switch our bounds because the function is decreasing in that interval. Let us take another example of a function which is decreasing always, 1 over x. This is a graph of 1 over x. We have 1 over x is always decreasing. That is why you see that as x is increasing, when x is positive, as x is increasing, you see 1 over x is decreasing. Even in this portion, as x is increasing, 1 over x is decreasing. For example, we know that 1 is less than 2. But if I take 1 over 1, it's not going to be less than 1 over 2. Rather, I'll have that 1 over 2 is less than 1 over 1. You see the function I'm applying here is the function 1 over x, and it is decreasing. That's why our inequality signs will either change or we just switch our bounds. Now, in the case where we actually have, because you see in this case, our f of x minus 6 is in an entirely negative interval from -11 to -1. That is why we have to be very considerate in applying the absolute value function. But if our f of x minus 6 was in a totally positive interval, we allow our bounds as such, meaning that when we take the absolute value, our bounds remain the same. But now if this f of x minus 6 was both in a negative and a positive interval, then we are going to begin the lower bound from 0, because we see that the absolute value in a positive region is always greater than 0. Okay, in fact, the absolute value function is always positive. You see it is above the x-axis always, no matter the value of x. The absolute value of x will always be either 0 or it's going to be greater than 0. All right, so let's now proceed to see how we can analyze this, like how we can proceed from this step. Okay, so we have had that -11 is less than or equal to f of x minus 6, which is less than or equal to -1. So from there now, since we need the absolute value of f of x minus 6 before we subtract 12 and take the reciprocal and multiply by 33, we need to actually see, okay, we have already seen previously that the function, the absolute value function, is decreasing in a negative interval. And since f of x minus 6 is in an entirely negative interval, it therefore means that if I want to take absolute value of the function, I'm going to switch the bounds. Okay, so I'm going to have rather absolute value of -1 less than or equal to absolute value of f of x minus 6 less than or equal to absolute value of -11. Just think about just taking the absolute value like that without switching. What are you going to get here? You get 11 less than or equal to f of x less than or equal to 1, which means that 11 is less than 1, which is impossible. So that's just a counter example to say that you have to be keen when studying, when taking absolute value, when introducing functions. All right, so from there now, we can simplify absolute value of -1 as 1, absolute value of -11 as 11. Okay, now I just switched the bounds to make it convenient for me. You could also change the signs of the inequalities. Okay, and when you do that, you're still going to switch the bounds, because if you take the absolute value here, you need to change the less than or, and you want to allow 11 to be here, you need to change the less than or equal to greater than. Okay, so that's if you want to do that, and also here, but switching the bounds is all right with that. All right, so from there now, since we have absolute value of f of x minus 6 lying between 1 and 11, we now proceed by subtracting 12. So we take 1 minus 12 less than or equal to f of absolute value of f of x minus 6 minus 12 less than or equal to 11 minus 12. If we simplify, we get here -11, and here we get -1. Now what we need to do next is that we have to reciprocate. So we have to take the reciprocal of f of x of the absolute value of f of x minus 6 minus 12, and we have already seen previously that the function 1 over is a decreasing function. It therefore means that if I take 1 over, I'm going to switch my bounds. So I'm going to take -1, 1 over -1 is -1, and I'm going to take 11 to the upper bound, because the function I introduced is a decreasing function. All right, so from there now, what next do we have to do? We need to multiply all through by 33, and since 33 is a positive number, the inequality signs will in turn remain the same. So here becomes -33, the center becomes the function I'm about to find its minimum value, and the upper bound is -33 over 11. Since I need the minimum value, means I need its smallest value, so we are going to take -33. If you needed the maximum value, you're going to take -33 divided by 11. So in a nutshell, the correct response is C. Alright, thank you guys for watching. If you want to prepare for your concourse using the MAFA website, you can just go to Google and you type www.estudyuniverse.com. Then you choose whether you want to prepare for medicine, engineering, teaching, administration, whatsoever. Okay, there you're going to find past questions and solutions to your various concourse in depending on the subjects. In medicine, in engineering, the engineering schools are divided into the engineering is divided into the various schools. We have FED, we have Public Works, we have Polytech Douala, we have NAPI, that's Polytech Bamenda, we have COT, and some engineering schools like Subtic as well. So if you need more guidance, maybe you don't know how to use the site well to purchase your past questions, my contact is on the screen, 6765979498, or you get to me via my email address. I'm going to respond to you. Alright, for those of you who have not subscribed, endeavor to subscribe to the channel, turn on your notifications so that whenever videos are uploaded, you always be notified to come and watch. Okay guys, see you in the next video, and thank you for watching.